All right, that last unit was quick. Now we're jumping on to lesson 3 or unit 3, pairs of lines and angles. Again, I think this stuff is pretty cool. This is like classic geometry stuff. I can identify pairs of lines and angles. So if we look at this is a cube here. We have lines parallel to CD and containing point A. So here's CD. So lines that would be parallel to them would be line AB, it could be line EF, and it could be line HG. However, there's only one line that is containing point A, which we would say is line AB or line BA. All right, so let's take a look at part B. Lines skew to CD. So skew means that they would intersect. Again, it also means that they are like on different levels. They're on different levels. So they're actually not going to intersect. They would intersect if they were on the same level. So skew would be FG because it's below it. It would be line EH, and it would be line GA, because again, if you think about it in 3D, these lines are never going to cross each other because they're on different levels, but they would cross each other if they were on the same level. And then, so again, containing point A, well, if I contain point A, that eliminates these two. So I'm only left with line GA or line AG. Part C, lines perpendicular. So again, perpendicular means create a right angle to CD and containing point A. So if I wanted to say, okay, what lines create right angles with CD, and it's this line, and it's this line, but only one of these lines contains point A, which would be line DA or AD. And my last example is looking at planes. So planes parallel to plane EFG. So EFG is my bottom plane down here and contains point A. So again, really in this example, there's only one plane that's parallel to it. And we have to use at least 3 letters. So I'm going to definitely pick one of them that uses point A. And I'm just going to say plane A, B, C. All right, now this is where it gets cool, in my opinion. So angles formed by transversals. So a transversal is just a line that cuts through 2 other lines. So this is my transversal right here because it's cutting through. So we talk about corresponding angles, and corresponding angles mean that they are in the same location. So if I were to draw up something here, okay, I've got 2 lines cut by a transversal. I would call this, if I'm just looking in a quadrant of 4, this would be my top left. This would be top right. Let's get a different color. Oh, shoot. So I'm going to call this top left, top right, bottom left, bottom right. But if you look, I have another quadrant of 4 right here. So I'm going to call this, again, get a different color, Mr. Larson. We're going to call this top right or top left. I am struggling right now. Top right. Oh, I did it again. Top left. Top right. Bottom left. Bottom right. So let's apply that. If I look at this example, corresponding angles, I see that I have the top right, angle 2, and I have the top right, angle 6. So we would say that angle 2 and angle 6 are corresponding because they're in the same relative location. They're both in the top right of the four quadrant. Then we've got alternate interior angles. So again, the word alternate means on a opposite side of your transversal. And the word interior means inside my two lines. So if I look again, I've got angle 5 is in the top left of my quadrant, and then angle 4 is in the bottom right. So bottom right, top left. They are separated by the transversal, which again comes with the alternate, and then they are inside of my two lines, which is where that word interior comes from. So that's called alternate interior angles. Well, if we've got alternate interior angles, we also have alternate exterior angles, which again, these are going to be on the outside of my lines. So I would say that this is top left and this is bottom right of their respective quadrants, and they are separated by this transversal. Again, they're on the outside, they are on the exterior or the outside of our two lines. And then this one, this is written as consecutive. I'm going to call it same side interior angles. So consecutive or same side, you'll hear me refer to it as same side. And again, inside my lines on the same side of the transversal. On the same side of the transversal. So inside of my two lines on the same side of the transversal. All right, so if we look at this, identify all pairs of corresponding angle of the given type. All right, so for part A, corresponding, there's going to be a lot of them. I can say that I have angle 1 and angle 5 because they're both top left. I can say I have angle 2 and angle 6, which are both top right. I can say I have angle 3 and angle 7, which are top right or bottom left. And then I have angle 4 and angle 8. Alternate interior angles. Okay, so again, alternate sides of my transversal. I have 2 and 7, and I also have 4 and 5. So angle 2 and angle 7, as well as angle 4 and angle 5. Alternate exterior, so again, on the outside of my two lines, that's going to be angle 1 and angle 8, as well as angle 3 and angle 6. And then my last one is part D, consecutive interior, which again is same side interior. Okay, well, I know that that's going to be angle 2 and angle 5. because they are on the same side on the inside, as well as angle 4 and angle 7, because they are on the inside of my two lines, same side of the transversal. So if I classify these, I see, okay, this is top left, this is top left. They are in the same relative location. So angle 1 and angle 5 are corresponding. I see that this is on the top right, this is on the bottom left, and they are on different sides of the transversal, and it's on the outside of my two lines. So I would say that angle 2 and angle 7 are alternate exterior angles. Alternate exterior because they're on the outside. Very similar, again, on different sides of the transversal, angle 5 and angle 4 are alternate. This time they're on the inside of my lines. I'm going to say alternate interior angles. Alternate interior. So make sure you start to familiarize yourself with these 4 different types of angles.